Pre-Cal. Today you're going to be learning how to multiply radical expressions. We're going to focus on multiplication only. It's really easy to multiply radicals. First thing I need you to do is check the index numbers. They have to be the same. Index numbers, remember, are the little numbers in the position of n. Secondly, you're going to multiply the radicands together, and then you're going to simplify your product. So you're going to take, in this case, A times B and write it as a product. And then if this simplifies, you will go on further. Make sure indices, index numbers are the same, multiply the radicands together, and then simplify last. Before we do the multiplication, just a quick review on how to simplify in the lowest radical form. The first example is the square root of 54, x to the 4th, y to the 7th, z to the 3rd. I've made a list of the perfect squares, or some of the perfect squares, to the side. Remember, this is an infinite set of numbers. Your first task is to pay attention to the index number. Because it's a square root, we are looking at the perfect squared list. 54 is not in this list. You are to find the highest perfect square that will divide evenly into 54. 1 always goes into that number, so we move to 4. 54 divided by 4 is not a whole number. 54 divided by 9 is. So we're going to check that. 54 divided by 16 does not work. 54 is not divisible by 25, or 36, or 49, and 64 is too big. So the highest perfect square would be the 9. So you're going to write this as 9 times 6. The square root of x to the 4th can be simplified. 4 goes divided by 2 is 2. So for right now, we're just going to leave it alone and simplify in the next step. We will not be able to divide the 7 by 2. It's not a whole number. So we're going to write y to the 7th as factors. Y to the 6th and y to the 1st. And then last, look at your z. It's raised to the 3rd power. We can't divide 3 by 2 and get a whole number, but we can write z to the 3rd as a factor of z to the 2nd and z to the 1st. And then, like we've done in the past, you go back and underline the pieces that simplify: 9, the x to the 4th, the y to the 6th, and the z to the 2nd. And then you answer. The square root of 9 is 3. The square root of x to the 4th is x to the 2nd. The square root of y to the 6th is y to the 3rd. And the square root of z to the 2nd is z to the 1st. And then whatever is not underlined means it can't be simplified, and it stays underneath the radical. 6, y, and z. And so that would be your simplified radical answer. Okay, example 2. Notice the index number is 3. So we look at our perfect cube list of topped out to the side. We notice that 54 is not in the list. So same way we've done in the past, we're going to simplify by writing 54 as a factor. So we're going to look over here. 8 does not go into 54, 27 does, and 64 is too big. So it has to be 27. 27 and 2. We can take the cube root of a to the 9th, so we're going to leave it as a to the 9th underneath the radical. And then b, try that again, b can be broken down into b to the 12th times b to the 1st. Alright, so let's see what happens next. So we got this key root. You're going to underline the pieces that you can actually take the cube root of. 27 is going to work nicely, a the 9th, b the 12th. And so the final answer, cube root of 27, since 3 to the 3rd is 27, the cube root of 27 would be 3. The cube root of a the 9th is a to the 9 divided by 3, so that'll be 3. And cube root of b the 12th is going to be b to the 4th power. And then after you simplify all the pieces that you can, then you drop down your cube root, and anything that can't be simplified, the 2 and the, looks like b, is going to stay underneath the radical. And that would be your final answer. Okay, again, that slide was just a review of simplifying radicals because you're going to have to use that in the process of multiplication. Now to our learning target on multiplication. Now to multiply the following, if possible, we're going to look at question number 1, and you notice that it's the cube root of 6 times the square root of 2. And recall that two things you want to check for are the indices have to be the same, index numbers, and then you multiply the radicands together. Well, because my example 1 has a cube root and a square root, that one we cannot do. And so basically we're just going to have to say not possible. Okay, moving to example 2, I see the square root of -4 times the square root of 2. Indices are the same, so I'm going to go ahead and continue. I'm going to get the square root of -8. Okay, next I'm going to have to write -8 as the square root of -1 times 8. And we know that's true because of the fact that we cannot take the square root of a negative number. No number times itself is going to be -8, and so that's why I went ahead and factored out the -1. Alright, and then we know that -1 is actually the I part, but one thing I need to do next is to write 8 as a perfect squared factor. So like 4 times 2 would be better. If I leave 8 underneath the radical, it is not simplified. So these are the two pieces I can actually simplify. The square root of 4 becomes 2. The square root of -1 becomes I. And 2 stays underneath the radical. And so this would be my final simplified answer for the product of the square root of -4 and the square root of 2. Okay, next we're going to look at example 3. On example 3, there we go. In example 3, you can see the square root of 10x to the second times 2 times the square root of 40x. And so I checked my indices. I noticed that these are the same. Grab my highlighter here. I've got a 2 that's understood there and a little 2 that's understood there, just not written. So they're both square roots, and I can continue. I'm going to go ahead and multiply, and when I multiply, if there is a number in the front, the 2 is actually being multiplied by the radical, Same deal over here. There's an understood 1. So I actually have to multiply the numbers outside the radical first. 1 times 2 is 2. Then I'm going to drop my radical down, and I'm going to multiply the radicands together. 10 times 40 is 400. So I'm going to drop that down. And then I'm going to do x to the second times x to the first, and that is going to be x to the third. Okay, next step, I'm going to continue to drop my 2 down, and I'm going to take a look at 400. In the perfect squared list, now the list we made went up to 100, but that list keeps going. And so one thing I want to make sure, caution you against, is don't jump too early. Always check the number first before you just go to your perfect squared list. Because actually, if you did type in the square root of 400, this one does simplify to a nice whole number. And so I'm not going to have to change the way I write 400 in this step. I'm just going to kind of bring it back down, and I will simplify this in the next step. And that's because I don't like this x to the third. I can't divide 3 by 2 and it be a whole number, so I'm going to write it as x to the second and x to the first. And that should take care of it. And then I underline the pieces I can actually simplify, which looks like those two. And so I'm going to drop my 2 down again, and the square root of 400 is 20. So 20 is going to come outside the radical, and in a minute we're going to go ahead and multiply that by 2. And then, but first we've got to do the square root of x to the second, and that's x to the first, and then the other x to the first stays underneath the radical. So it looks like 2 times 20, I'm going to have 40, and then x, and then the square root of x. And that should take care of it. That is the simplified version. Okay, number 4. First, we want to check out the indices again. We notice there's a 2 square root here, square root here, so we're good to go. We can continue. We're next going to multiply the radicands together, so I got like 12 times 6, and that's going to be 72. I have m to the third times m to the second, and that is m to the fifth. Add powers when you're multiplying. And then n to the fifth times n to the first is going to be n to the sixth. And then I'm going to check out 72. If 72 is a part of a perfect squared list, then I can simplify like this one, but it's not. So we're going to find the highest perfect square that divides into it. 4 works. 9 also works. 9 times 8. 16 does not. 25 does not. 36 does. And so let's see, 36, after that's 49, and then 64, it's getting too close. So 36 sounds like the biggest value, and we're going to use it. 36 times 2. And then the square root of m to the fifth. Okay, I can't do 5 divided by 2, and it worked nicely. So I'm going to write m to the fifth as m to the fourth times m to the first. And then we're going to go with n to the sixth and leave that one alone, which is good. So we're going to take this one out in a minute, and this one, oops, and this one. And so final answer, the square root of 36 is going to be 6. The square root of m to the fourth is m to the second. The square root of n to the sixth is n to the third. And then we got that radical, and then we're left with a 2m. And that should be your simplified answer. So multiplication is pretty straightforward. Just always make sure you give me the simplest answer that you can.